All right, welcome to A1 Tutor Live class. Welcome to physics class. And today we are going to be considering a new topic, which is work, energy, and power. Work, energy, and power. Work, energy, and power. So we are going to be considering this topic today. And for today alone, we are going to be working on work. So energy will be in the next class. Like I said, we'll be working on work alone for today, and energy will be taken in the next class. Okay, I believe you can hear me and you can see the screen. You can see what I'm writing on the board. So please kindly signify with your emoji. Let me be sure that you can hear me. Okay, thank you, Naima. So we are working on work today. And when you hear the word work, yes, literally we have work as occupations. So some you can actually say I work at so place, because work can also be synonymous to what we call occupation or profession. Okay, but we are looking at work in the context of physics. Work in the context of what? Physics, not the literal meaning now, but in the context of what? Physics. Is that taken? So that's what we want to discuss today as a topic. And we are going to touch everything that has to do with this topic work, and we are going to perform some calculation on it. Okay, now to introduce this, let's quickly um, take an illustration. Let's take an illustration. Okay, let's consider an illustration. Okay, so now I've sent some pictures that we're going to be using for the class today. So we check those pictures and we are going to be working with them one after the other. So to introduce the topic, let's consider this illustration. Or if you can see the picture, please thumbs up. You can see the picture I'm presenting on the screen, thumbs up. If you can see the picture I'm presenting on the screen, thumbs up. If you can see the picture from your hand, please thumbs up so that we can continue. All right, so I believe everyone can have an access to that. Okay, so this picture here we are going to use to introduce what we mean by work. Okay, for work to be done in physics, there are some things that need to be considered. Okay, now let's look at this man standing here. You can see this man. This man we have here is pushing the wall. Okay, is pushing the wall, and of course the wall is fixed. It can't move. the wall can't move. It's fixed, right? Now the man here is holding an object, okay, and is moving towards this direction. Okay, is moving towards this direction. So we have two scenario here. We have two scenario. The first man here is pushing the wall. Of course, the wall cannot move, so you keep seeing him pushing it and pushing it. Even you observe some minutes after that, he was sweating seriously. And if someone seeing peradventure, they will say, ah, this man is working actually, because why? He's sweating. Of course, that is not work. What he's doing is not yet work. Now, let's consider this. This man here is walking towards this direction and is holding an object that actually has a weight and is walking to this direction. Now, between Mr. A and Mr. B, who has performed work? Who has performed work? If I'm asking you that between A and B, which one can we refer to as work done? I need your response in the chat box. Between Mr. A and Mr. B, who has performed what we call work in the context of physics? I'm waiting for your response in the chat box. Between Mr. A and Mr. B, between Mr. A and Mr. B, between Mr. A and Mr. B, who has performed work? Okay, that's my question. I said between Mr. A and B, who has performed a work? Mr. A is pushing the wall, and the wall is static. It can't move. Mr. B is holding an object in his hand and is moving towards a direction. Is moving towards a direction. Is moving towards a direction. So my question is, among the two people we have here, among the two men, who has performed work? Is it Mr. A or Mr. B? I'm waiting for your response. Just type A or B in your comments in the chat box so that we can proceed. Just type your response, whether A or B in the chat box. Okay, from what we've explained, Mr. A is not performing work. No. Mr. B is performing work, because in physics, we consider work to have been done if there is a displacement. That is, the person or the object is moving from one point to the other. Okay, not that just force to be applied, but after force have been applied, there should be a displacement in direction to that force. In direction to that force. So if this man is applying a force in this direction, we are expecting the wall to move, but the wall is not moving. So it is not work. But for this man, he's applying force in carrying this load and is moving in this direction. So force was applied, and there was also a movement. There was a displacement. Okay, there was a displacement. A distance was covered in that process. Okay, and that is why mathematically we say work done is force times distance covered. Force times distance covered. Okay, so the man pushing the wall is not performing any work. He can be sweating seriously, but that does not mean he's performing any work. Okay, until there is a displacement of that object which is applying force to before we can consider it as work done. So the wall is not moving. So Mr. A is not performing any work, but Mr. B is performing work because the object is holding, which he has applied a force to, is also moving towards a direction. Is moving towards a direction. So there's displacement. There's a distance covered for Mr. B. I believe that is clear to us. So that will now bring us to the concept. This is the concept of work done, and this will bring us to the main aspect of our work today. We are going to consider some subtopic under work done. So if this introduction is clear to us, please kindly signify. So we'll move on to the next subtopic that we have to touch. Signify if the introduction of work is clear to you. Signify with your emoji, or you can type yes in the chat box. I want to be sure that we are following me. I want to be sure that we are all on the same page. So if the introductory part is clear, please thumbs up, and let's move on to the next thing. Okay, thank you, Peace, for your response. Awesome. So let's move on to the definition of work now. So I'm going to stop presenting the picture and move to the board. So let's consider the definition of work. All right, so we have the definition of work on the screen. Work. Work is said to be done. Work is said to be done. Underline the word done. Work is said to be done when force applied, to a body moves the body a distance, in the direction of the force. Work is said to be done when force applied to a body moves the body. Can you see that? Moves the body. So any body, objects that you are applying force to, if you are going to say the work can be classified as work done, that means that object or that body has to move a distance, at least a distance. Okay, it has to move a distance to the direction of the force applied. So if I'm moving an object, I'm actually applying a force to an object in this direction. That means the object will be moving towards the direction of the force where I'm applying the force to. Okay, so to explain that, if this is a man, okay, and let's say this a table, and the man is pushing this table, okay, he's applying force, and what you're going to discover is that the table is moving in this direction. There will be a movement towards this direction. Okay, force was applied to the table, and the table will move in this direction. So it is expected that for work to be done, force have to be applied to a body. The body have to move to the direction of the force applied. The body have to move to the direction of the force applied. And the force and the distance in the direction of the force applied, okay, still in the definition, we are given the unit of force to be Newton. The unit of force to be Newton. When we are solving calculations, we need to take note of that. And the unit of x, which is distance or displacement, is what? Meter. Is what? Meter. Okay, so we can say that our SI unit or the unit of work done should be Newton meter, but the SI unit that is accepted generally, SI unit means System International Units. Okay, so the System International Unit that is accepted for work is what? Joule. Is what? Joule, which is represented by letter J. So letter J, which is Joule, is the what? Is the unit of work done. Is the unit of work done. Okay? To buttress more on the definition of work done, let's consider this picture. Okay, so looking at this picture now, this is the definition of what? Work done. The definition of work done. So we have a man carrying a what? A load. So force was applied in this direction, and the object also is moving. The object is moving in what? In this direction. It's moving in the direction of the force, carrying a load upward. The force is applied in this way, so the load also moves in the direction of the force. From the definition we considered the other time. And there's a displacement. The object probably was on the floor. From the floor, it's now at this moment. So we have a distance covered from this place to this place, which is what? S, distance, displacement. So the object was moved from the floor to that level. So there is a displacement. Okay, so you have to take note of those key things. If there's not displacement that has been done, it is not work done. Okay, so displacement has to be part of it. Force have to be applied. Okay, and the object have to move from its initial position to another position. Okay, so by doing that, we have performed a what? A work. Is that taken? So that is the definition of work done. I believe we are still together. If you are still with me, thumbs up as we continue the class. If you are still with me, thumbs up. If you are still with me and you are following, thumbs up. If you are still with me and you are following, please thumbs up. All right, okay, thank you. So the definition of work is clear to us. Let's move on to the next. So we are going to clean the board and pick up the next thing. So let's look at the conditions to be considered. Okay, the condition to be considered. So let's take a look at this together. The conditions to be met before work can be done. The conditions to be met before work is said to be done. These questions comes in UTME. Yes, they will give you questions like this. What are the conditions for you to say a work has been done? Number one, force must be applied. Force must be applied. That's the first condition. Force must be applied in what? In work done. Force must be applied in work done. Okay? So we have another one. The force must cause the body to which it is applied. Take note. The force must cause the body to which it is applied to move through a distance. If the force is not causing it to move, you have not done any work. Okay? You have not done any work. So that is the second criteria or condition. The force you are applying to that object must cause the object to move a distance. Okay? And the third one is that the distance moved must be in direction of the force. The distance moved, that is the movement of that object or the body, must be in direction of the force, like the image we used initially when we were defining force. Okay, it has to be in direction of the force applied. Is that again? So these three criteria or condition must be considered before we can say a work is work done. Okay, it has to be considered first. It has to be considered first. I believe those condition is clear to us. If the conditions are clear to us, please thumbs up. We are moving to the next subtopic. We have a lot to cover. The conditions to be met before work is set to be done. If it is clear to us, please let's thumbs up so that we can move to the next. All right, so let's pick up the next one. We want to look at examples of work done. Examples of what? Work done. Examples of work done. Okay, so we have cases of what? Work done. Cases of work done. Cases of what? Work done. So these cases are going to depict work that has been done. The first one is a table pushed from one point to the other on a floor. A table pushed from one point to the other. A table pushed from one point to the other on the floor is an example of what? Work done. Is an example of work done. And that we can explain using this illustration. Okay, take a look at this picture. Can you see the picture? If yes, please thumbs up. Can you see the picture? If you can see the picture, please thumbs up. If you can see the picture, thumbs up so we can move on. The picture I'm presenting is on the screen. So looking at this example, this is work done. The man is pushing a what? A table. So force is applied in this direction. Force is applied in this direction, and the table also is moving to that direction, and that is push. Now let's look at pull. So this man here is pulling the table to this way. So the force is applied towards himself, and the table also is moving towards the man. Okay, so that is why we said that work done, when you apply the force to an object, the object has to move in the direction of the force applied, and that can be depicted in the two images we have here. So force is applied in this direction, okay, and also the object moves in that direction. Okay? So an example of what? Work done. Example of work done. So this is an example of what? Work done. Okay, let's look at the second example of work done. Number one, another one is a bucket of water being lifted from the ground. A bucket of water being lifted from the ground. So when you lift up a bucket of water, you have performed work because the bucket was on the ground and you applied force to carry it. And when you carry it, the bucket was moving in the direction of the force you applied. Okay. and it was moved from the ground to the space. That is where you are holding it. At that level, you are holding it. So that's an example of what? Work done. What about a man climbing a tree? Is also work done. A man climbing a tree. Okay, let's look at that. A man climbing a tree. So let's look at this picture. We have a man. This man is climbing a tree, right? So he's also performing work. Work is done here because he's moving. He had moved from this point to where he is. So we have what we call displacement. Displacement here. Displacement has taken place, and he's not just moving if he's not applying force. He's applying force, and that is why he's moving. So he's applying force while he's holding the tree. He's applying a force to move in the upward direction. So force is applied, okay, and the distance is covered, which is s. So work done here will now be force times what? Distance covered. Force times distance covered. So a man climbing a tree also is performing a what? A work. Okay. A man climbing a tree is also performing a work. A man also coming down of a tree is also performing a work. Yes, because there is a displacement from the top of the tree to the ground. He had to apply a force to be able to come down. Also, when he's climbing, he has to apply a force to what? To be able to go up. So that is also what? An example of what? Work done. So this is an example of what? Work done. I believe we are following. If you are getting me, please thumbs up and let's continue the class. If you are getting the explanations, please thumbs up, react, give me a reaction with your emoji so we can continue. Or if you have questions, please drop your question in the chat box so we can proceed. And we are going to attend to the questions together later. So if you are following, thumbs up. If you are getting the concepts of work done, thumbs up, and let's proceed. I'm waiting for your reaction. I want to be sure that we are all together and we are following and we are actually getting what we are discussing here. So if it's clear to you, the examples we treated, examples of work done, please thumbs up and let's proceed in the class. Okay, thank you, Peace, for your response. All right, so let's proceed. So we've discussed about a man climbing a tree. That is also what? A work done. Now we have some cases that are not considered to be work done. So let's look at those cases. Some cases that are not considered to be work done. Okay, so let's look at those cases that are not considered to be work done. Okay, let's consider this case. These cases. Now, cases of work not being done. Cases of work not being done. The first one, a girl standing with a bucket on her head. A girl standing with a bucket on her head. That means she's just standing, the bucket is on her head. She's not moving an inch. Okay? Of course, she's applying force to maintain the bucket on her head. But for the fact that she has not moved an inch, that means she has not performed any work. She has not performed any work at all. So if you are holding a load and you are standing on a spot, you have not performed any work. Okay? So that are cases that are considered to be work not being done. Okay? A boy pushing a fixed wall. A boy pushing a fixed wall. I think we've used a diagram for that. A boy pushing a fixed wall. A boy pushing a fixed wall. So I think this is what we used the other time. Look at this boy. He's pushing a wall, but the wall is fixed. The world is not moving. All right. The world is not what? Moving. Okay. So this is considered to be what? A work that is not being done. Okay. Here, work is not being done. But in this case, work is being done because the man is moving with the object he's holding at hand. Is that taken? Okay, so those are the two cases, or we have many. Somebody sitting down. What is an example of that? An example of work not being done. Okay, so I want you to give me in the chat box some example of work not being done. Can I have some example of work not being done from your own hand? Just type it and send it in the chat box. Example of work not being done. Type them and send it in the chat box. I'll be waiting for that. Keep sending them inside the chat box as we proceed. Give me example of cases where we can say work has not been performed. We've mentioned a girl standing holding a bucket on her head. We've mentioned a boy pushing a fixed wall. So those two cases that I mentioned are not work being done. So I want you to give me examples inside the chat box, and I'll be expecting that while we proceed with the class. You can drop your example in the chat box. Example of work not being done. Okay, I'm going to give us a picture now. Then I will ask to tell me whether it is work done or work not being done. Okay, looking at that picture on the screen, just tell me, work, is it work done? Is it work done? Is this work done? So I need your response whether yes or no. The boy is climbing the staircase. The boy is climbing the staircase. He's climbing it to what, to the top. So is it work done or work not being done? Yes or no? Is this work done? Just tell me whether yes or no. A boy climbing the staircase. So waiting for your response. Is it yes or no? I'm waiting. That diagram, does it illustrate work done? Just tell me whether yes or no. You can type in the chat box your response. Just tell me whether yes or no. The boy walking on this staircase, is it performing work? Yes or no? I need your response in the chat box. I'm waiting for your response. I want you to type yes. Don't use emoji. Yes, thumbs up. That's good. I want you to type yes in the chat box. Check your chat where I send the message. Just type yes, or if it is no, type no. If it is yes, type yes. Thank you, Olani Miriam, for your response. So thumbs up means yes. I want to have one more response. Okay, yes, thank you. So it is work done. Okay, let's consider another one. What about this case? Is this also work done? Okay, look at the picture. Is this also work done? Is moving while he's dragging this particular load, okay, and he applied the force, he covered a distance of 30 meters. So is this also work done? Type yes if your response is yes. If it is no, let me know. Type your response in the chat box. Is this picture depicting work done? Is this work done? Question mark, yes or no. I need your response in the chat box. Yes, okay. Thank you, Miriam, for your response. Awesome. That's a great response from you, Miriam. Okay, so lastly, we'll take one more illustration of picture. You are going to tell me if it is work done or not. Then we'll move to the next thing, which is calculation. Calculation. Yes. For this picture also, is it work done or not? Is this work done? Yes or no? Okay, thank you for your response, please. It is what? Work done. It is also work done. Now, I want to give us one, which is very tricky. One of the picture is very tricky here. Yes, this picture. I want you to tell me whether it is work done or not. I believe you all know this. This is a Ferris wheel. We call it the Ferris wheel. It is found in amusement park and it rotates like this. It goes like this, like this, like this. So this Ferris wheel, can we say the motion it performs is said to be work done? Is this work done also? So I need your response in the chat box. Okay, peace. Are you saying yes? Is this Ferris wheel, is it performing work also like this? Is it performing work? I'm waiting for your response. Do we have any response? Is this Ferris wheel performing work done also? Yes. I want your response, either yes or no. Please give me your response. Is this Ferris wheel performing work, yes or no? Let me have your response. Waiting for your response, waiting. Any response? All right, okay, let's proceed. The Ferris wheel is not performing any work, okay? The Ferris wheel is not performing any work. As a result of this, we are going to bring in what we call the centripetal force. Centripetal force is a force that moves an object in a curved path. Okay, centripetal force. Okay, let me use a black ink so we can see this. Let's have it here. All right, so, okay, I think it's better like this. Okay, so a centripetal force is a force that makes a body to move in a curved path. So you look at this object, this body, which is the Ferris wheel, is just moving in a curved path, and it's fixed. It's not moving from one distance to the other. There's no displacement. Displacement in physics is the movement from one point to the other. Okay, so this Ferris wheel is not performing that movement. It's just moving round, round a what? A curved path. So because it has not experienced what we call displacement by moving from a point to another point, so we say a what? A Ferris wheel is not performing work. What is at work there is what we call is centripetal force, a force that move an object or a body round pattern or a what? A curve. Have a car riding round, what's it called? A roundabout. Okay, the car is just going around the roundabout. It has not performed any work until a displacement is covered, until a distance is covered. Okay, so take note of that. You can be asked question in CBT that which of the following is not work done, and they will give you a man climbing a tree, um, a man pushing a table, and they will say, okay, a Ferris wheel rotating. So your answer should be what? A Ferris wheel, because a Ferris wheel is not performing work. Okay, force is applied, but there's not displacement. There's not displacement. It's just moving around a fixed point. A fixed point. I believe that is clear to us. If that is clear to us, please thumbs up so we can continue. If that is clear to us, please thumbs up. All right, so I believe we can proceed. If that is clear to us, please let's react. I need your reactions. I want to be sure that we are still together and we are getting what we are doing. All right, so let's proceed to the calculative aspect, calculations. So we have calculations. Calculations on work done. Calculations on what? Work done. So let's consider the first application. A load is pulled 5 meter long, 5 meter along a horizontal floor by a constant force 20 Newton, which acts at 30 degree to the floor, calculate the work done by the force. Calculate the work done by the force. So we have this question to solve. UTME 2000. UTME 2000. Okay. So we want to solve this question. We said earlier that force equals to, or work equals to force times distance covered. Okay. We also have another formula that work equals to F, which is force, times X cos theta. That is when we have an angle of inclination. An angle of inclination. So if you are carrying a load on an inclined angle, let me say an inclined surface, that inclined surface is going to make an angle with the ground. So that angle is what we have as what? Theta. That angle is what we have as what? Theta. So these two formula we are going to use, and also work done in fields. Okay, we have gravitational fields, like we discussed in our previous classes when we were talking about gravitational force. We have gravitational field. Okay, work done under gravitational field is mgh, which is mass, gravity due to acceleration, and height. So we are going to be using these three formulas to be solving questions. Okay, take note of these three formula. Work done equals to force times distance, or work done equals to force times distance cos theta, or work done equals to mgh. So this is when we have a linear displacement, that is a straight line displacement. This is when we have an inclined surface, and this is when we have a falling, or what? A falling or rising object, okay, due to gravity. A falling or rising object due to gravity. So for this question, the first thing you need to do if you have to solve this question is first to identify your what? Parameters. That will make the solution simple. Okay? A load is pulled 5 meters along, 5 meters along an horizontal floor, which means 5 meters is the what? The distance covered on the ground when it was moving. Okay? So distance is represented by S, that is 5 meters. The distance covered was 5, and it was acted upon by a force 20 Newton. F equals to 20 Newton. And that object that was pulled on the ground, on that horizontal ground, forms an angle 30 degree. So theta equals to 30 degree. So looking at all these parameters, it will tell you which of the formula to use. I have S, I have F, I have theta. So I'm having formula 1, 2, 3. Which formula do you think I'm going to use? Tell me in the chat box, which formula are we going to use to solve this question? Is it formula 1 or 2 or 3? Just type whether 1 or 2 or 3. Which formula is suitable to solve this question? Which of the three formulas is suitable to solve this question? 1 or 2 or 3? I'm waiting for your response. Waiting for your response. Is it the first formula or the second one or the third one? Looking at the parameters, we have F, we have X, we have theta. So we are going to use the second formula. This formula is what we're going to use. So my work done equals to F S cos theta. That is equals to force is 20 times X is what? 5 cos theta is cos 30 degree. And that is going to give me 20 multiplied by 5 is 100 cos 30 degree. So 100 cos 30 degree, using your computation, using your calculator, you are going to have the response, okay, 86.6. 86.6, that will give us 86.6 joule. 86.6 joule. So we have 86.6 joule. So the work done is what? 86.6 joule. 86.6 joule. Always important to use your what? Your SI unit in physics. Always important to use your what? SI unit. Okay, is this first application clear to us? If it is clear to us, please kindly signify before we move to the second one. Quick response needed. If the first application is clear to us, please kindly signify. If this first application is clear, please thumbs up and let's move to the second application. Thumbs up if the first application is clear to you, so we can move on to the next one. I believe we are still together. If the first application is clear, please thumbs up. Let's move on to the next application. I'm waiting for your response. Okay, so that means we can move to the second application. So permit me to clean the board while we take the second application. Up to a load, okay, of mass 80 kilogram fell down. A load of mass 80 kilogram fell down from the floor, fell down from the floor of a lorry, which is 1.3 meter high, 1.3 meter high. Calculate the work done. Calculate the work done by gravity. When you hear the word gravity, so you should know that we are talking about work done in gravity fields. The gravity, calculate the work done by gravity on the load. On the load, take G equals to 10 meter per second square. Take G equals to 10 meter per second square. So we want to solve this question together. So we have a load of mass 80 kg. The first information was mass, which is M, was given to be what? 80 kg. Fell down from the floor of a lorry, which is 1.3 meter high. So the height of the lorry, okay, this is the lorry, okay, and this is the floor. So the height here is 1.3. From the lorry to the floor is what? 1.3. Okay, so height, which is h, is given to be 1.3. And another information that was given is what? The constant of gravity, which is g, equals to 10 meter per second square. And we are asked to calculate the what? Work done by gravity. Work done by gravity is going to be mass times gravity times height. That was the third formula I made mention of the other time in the first application. So work done will be equals to mass times gravity times height, and that will give us mass is 80 times gravity is 10 times height is 1.3. So when you multiply this out, you are going to have 1040 joules. 1040 joules. 1040 joules is going to be the what? The work done. Take note, if your mass is not given in kilogram, you need to convert to kilogram before you can solve the question. All right? I believe that is clear to us. If the second application is clear, thumbs up. While we are moving to the evaluation period, I have few questions to ask us. So if the second application is clear to you, thumbs up, and let's move to the evaluation period. I'm waiting for your reaction so that we can move to the evaluation period. If application 2 is clear to you, please kindly thumbs up or signify in the chat box. Okay, all right. Okay, let's move on with our question now. So I have some questions for us. Yeah, some questions to answer. Okay, this question is for us, and you're going to type to give me your response in the chat box. So look at this question. Tell me your answer in the chat box. Work is done, is said to be done. Work is said to be done when option A, option B, option C. So tell me your response in the chat box. What is your response for that question? I'm waiting for your response. What is your response to this question? Is it A or B or C or D? What is your response to this question? Okay, all right, good response. Okay, thank you for your response. B, thank you for your response. B, correct. B is correct. Thank you, Peculiar. Thank you for that response. B is correct. Force is applied and the body moves in the directions of the force. Awesome response. Okay, the next question. The next question. Okay, this is the next question. Okay, we have a question here. Calculation. Force was given to be a value. We have force. So read the question and give me your answer. Force was 25 and distance, which is S, was 6 meters. So we are asked to find the work done. So what will be the work done? Very quick one. Waiting for your response. Waiting for your response. These are UTME questions. This is UTME question 2003. So what will be your response? What will be the work done? The work done. I'm waiting. Is it going to be 100 joules? Is it going to be 120 joules? Is it going to be 150 or 200 joules? Take note, the formula we have for work done is F times X. Work done is mgh. Work done is Fx cos theta. So look at the formulas I gave out here and pick the correct formula, then solve the question and let me have your response. I'm waiting for your response in the chat box. What will be the work done? I'm still waiting. What will be the work done? Still waiting. C, correct, peculiar, awesome, great response. 150 joule. 150 joule is the response. Okay, thank you so much for your time today. We've been able to cover up for work done. Tomorrow, we are going to continue with what? Energy. So today we've discussed the definition of work done. We consider the condition for work done, and also we considered some cases that are work done and some cases that are not work done. That is, some cases that are considered to be work done and some cases that are considered to be work not done. Okay, and we consider also some pictures to ask ourselves question whether those pictures are depicting work done or not. And we went ahead to do some calculation in the aspect of work done. There are still more calculations to practice, and I'm going to refer us to A1 Tutor app. Do well to visit the A1 Tutor app, okay, to practice more questions, okay. Go to the CBT section of the app and practice more questions on work done. Is that okay? And for the sake of our friends that are unable to join today's class, they do not have to panic. Just tell them to visit the YouTube channel and search for A1 Tutor and watch today's class videos there. Okay, thank you for your time. Let me have your reaction as you are leaving already. Thank you for your time. Thank you for your time. Thumbs up, thumbs up, thumbs up. Okay, thank you. See you tomorrow. Tomorrow is another day. Ensure you do not miss the class. Bye.